Okay, are you able to hear me?
Yes, sir. Audible, sir.
Okay, right. So we'll start the class now. So yesterday we asked you solve this particular problem. I think only some of you solved it, but still I'll show you the solution for this problem also. Then we'll take up the next problem. So like I discussed here in the previous class, the data is given. Power to be transmitted is 22.5 kilowatts. Speed of the pinion is 1450 rpm. Number of teeth and on pinion and gear also given 20 and 50. So SUT is given as 410. So this is for the pinion. Then SUT for the gear is 200 because here gear and pinion made of two different materials. You need to decide which one is the weaker. You need to find out what is the sigma B into capital Y. That is the Lewis form factor. So for that sigma B is nothing but SUT by 3. Generally we will take SUT by 3 as the sigma B for this gear materials. So and also has given the rated torque is 150% the starting torque is 150% of the rated torque. So that is also mentioned here, and factor of safety is given as 1.5. Okay. Ask us calculate what is design the gears based on this equation and use velocity factor to account for the dynamic load. That's what he has given. So first we need to decide which one is the weaker. For that we required sigma B as well as Y. So now this Y Lewis form factors are taken from the data book. For 20 and 50 things from the data book, they are the values 0.3 to 0.408 respectively. Maybe you may get the different values, so don't bother about that. Provided if you taken properly from your data book, you proceed with those values. So here these values are taken from the data given in the textbook. So if you refer the data book, whatever value you got it, you take that exact those values and you can proceed. No issue with that. Then for pinion, we'll find out what is sigma B. Sigma B is nothing but 410 by 3, which is 136.67 Newton per mm square. Then sigma B into Y, product of sigma B and Y is comes out as 43.73. Similarly, we'll calculate the sigma B, product of sigma B and Y for gear also. For gear, sigma B is 66.67 because he has given SUT as 200 Newton per mm square, and then Y is 4.408. Then if you calculate the product of sigma B into Y, you got it as 27.2. So now out of these two, 27.2 is the least one and compared to 43.73. So therefore gear is going to be the weaker one. So that means you need to design the gear, you need to design the drive based on the gear, not based on the pinion, because gear is the weakest one here. So then the product of sigma into Y is less. For the gear is the weaker than the pinion, and it is necessary to design the gear. So design is nothing but we need to estimate what is the module. So for that, he has given speed of the pinion and number of teeth on the pinion and number of teeth on the gear. So using those relations, we can find out speed of the gear. So that is nothing but the formula is Ng by always the speed is inversely proportional to the number of teeth. So that means Ng by Np is nothing but Tp by or Zp by number of teeth on pinion divided by number of teeth on gear. So using this relation, then if you want to calculate speed of the gear, Zp by Zg into Np is going to be your speed of the gear. So using that formula, Zp is given, pinion number of teeth on pinion is given as 20, number of teeth on gear is 50, and speed of the pinion is 1450. From that you'll get 580 rpm. Why you got this one is to calculate that V velocity factor, we require this Ng value. Then we will assume, because initially we don't know what is V, we are assuming it as 5 meters per second. So based on that, your CV is going to be 3 by 8 and B by M is assumed as 10 again. Then you substitute all those data in the CS is given as 1.5. CV is just using this relation, we calculated 3 by 8. So everything we know now here. So if you substitute the corresponding data, here it is not G. You need to substitute for gear. Here it is a mistake. So 50, all this data, power transmit to be transmitted is 22.5, CS is 1.5, FS is also 1.5. ZG, number of teeth on gear is 50, speed of the gear is 580, and the CV is 3 by 8, B by M is taken as 10, and SUT for the gear is 200, and Y is for gear is 0.408. So if you substitute and if you calculate this, you get it is 6.89. So now we need to choose 6.8 from the 6.89. Next, we need to decide what is the value. So, like I said in the data book, you have a tables for SIAM, like a columns first choice, second choice, and so on. Third choice also there, I think. So he has given the values. So you don't have 7 mm in the first choice. In second choice table, you have a 7 mm. So then, as a second choice, you can choose 7 mm as a your pitch value. Or else, if you want to choose only first choice values from the first choice or preferred values only, after 6 you have 8. You don't have 7. You have 8. So therefore, whatever you want to choose, take the second choice, take modulus 7 mm, or you want to choose the preferred choice, which is 8 mm. So you can take either 7 or 8. It doesn't matter. There is nothing wrong in the taking either 7 or 8. So in this problem, you selected the standard value for module under choice 2. That is second choice column. In that second choice column, the pitch 7 mm is there. You selected like that. So then, once you selected the pitch, again you need to calculate the parameters of the gear, and you need to check whether this 7 mm parameter is giving that 1.5 factor of safety or not. If the factor of safety is less than 1.5, you need to change the module and you need to redesign it. If it is okay, then we can proceed with that. So now with trial 1, modulus 7 mm, and then you can calculate, once you know the module, you can calculate the diameter of the pinion, diameter of the gear, as well as pinion. So diameter of the pinion is given by M into number of teeth on the pinion, which is 140 mm. Then you can calculate the diameter of the gear also, which is 350 mm. Then face width B is 10 mm, which is 70 mm. Then we can check for the design. So for that, first we will try to compute what is the torque to be transmitted. So formula for that is 60 into 10 power 6 kilowatt divided by 2 pi. Here you can use NG or NP. So generally, because we are designing based on this gear, so you take the gear values here. So it is 580. So NG is 580. To substitute that, it is going to be the torque. Then from this torque, you can calculate what is the PT. So PT is nothing but 2 MT by. Here the thing is, if you take here NG, here you have to take DG. That is the point what you need to remember. Here if you take NP, that is speed of the pinion. Here you have to take the diameter of the pinion you need to take. So that is the thing what you need to remember. Okay, there is no issue. As long as whatever you take in here, you take the same thing, there is no issue. Whether you are considering pinion or gear, it doesn't matter here. Just only while calculating the torque and this PT. But while designing earlier things, so you have to follow the gear symbols only. So that's why here he has taken the only gear parameters only in this case also. But if you want, you can take NP and DP also, no issue here. But as long as the above parameters, selecting up to this point, selecting the model, you have to choose the gear parameters because gear is the weaker one. Right, now with this, you got PT as 2116.84 Newton. Then you can calculate. See here, he has used here now pinion forward. So you can use pinion or gear, it doesn't matter. Here, you can replace this one, DG dash, that is pitch circle diameter of the gear, and NG. If you substitute that also, you will get the same 10.63 only. So it doesn't matter, that's why you are using pinion or gear parameters. So once you got this V, again using this V, which is 10.63, you need to recalculate your CV value. So that is 6 by 6 plus V for this, so which comes out as 0.3608. So in yesterday's discussion, somebody told that in the new edition of the data book, the CV is given as something like this. CV is equal to 6 plus V by 6. I don't know whether I have not verified it. If this is the case, then what you have to do is While calculating the effective load, you have to take 1 by CV. That is the modification you need to do it. If it is like this, then there is no issue. As it is, you can use it and you can solve the problem. If it is in the reverse way means, while applying that CV to the effective load, you need to reverse that value also. Always, or else you remember on thumb rule. If CV is less than 1, you take that one in the denominator. If CV is more than 1, you take that one in the numerator. That is the only thing. So here, why we need to take CV is less than 1, it is in the denominator, and CV is more than 1, it is in the numerator, because this CV is the velocity factor which will compute the dynamic load. So that means we know the static load from the beam strength. Now we are modifying that static load to the dynamic load. Always the dynamic load is going to be more when compared to the static load. So that means always your effective load should be increased if you want to calculate the dynamic load. So that's why, so if it is less than 1, if you take it in numerator, so it will increase the magnitude of the P effective. If it is more than 1, we need to multiply it. So you need to take it in the numerator. So with that, the load will be multiplied. So you remember that one. If he has given the formula like that. So once you calculate the CV value, then you can calculate effective load. So CV by CS by CV into PT, that's what I said. If it is less than 1, it will come in numerator. If it is more than 1, if it is less than 1, it will come in the denominator. If it is more than 1, it will come in the numerator. So accordingly, you do it. So if you refer data book, he has given in the, I think maybe he has given in the numerator only. So you don't have a denominator for that. You can take like that also, no issue. So now, here what we need to do is we need to substitute the given data. Just now you calculate it. So then you'll get the your effective load as 88,800 newtons. So once you have effective load, then you can calculate the beam strength. Then based on that, you can find out the back cross safety. Beam strength formula is this one. MB into sigma B into Y. If you substitute the respective values, you get sigma beam strength is SV as 13,328 newtons. So then your factor of safety, you need to verify for the factor of safety, which is nothing but SB by P effective, which comes out as 1.51. But required factor of safety is only 1.5. But here we got 1.51 means whatever module you choose in M, that may be satisfactory or it may be okay for the given application. Suppose here instead of 1.51, if you get less than 1.5. So whatever module you got it is, if that whatever factor of safety you got here in this calculation, if it is less than 1.5 means you need to take you need to go for trial 2. That means you need to take the next second module, trial 2. So for second choice we are taking it as 7 mm. Then we'll go for the preferred choice. In that the module after 6 for 6, it is going to be 8 mm. We'll take 8 mm as a module and we'll try to again do the calculations and we'll check whether now the factor of safety is improved or not. So if not, then you need to go for trial 3 like that, you need to do it. So luckily here with 7 mm it is satisfying, so no need to do the iterations here. With 7 mm you are getting a factor of safety of 1.51, that means no need to do the iterations, so we can start the problem here itself because your design is satisfactory even in the first trial itself. Okay, so this is how you can solve the problem. Then we'll take up, we'll see some more problems. Then the next problem is like this. So we note down this problem. Here it is noted for mm square. Note down this problem. Then we'll discuss the solution. So it is also similar, but only thing is it is a reverse way of solving that particular problem. So in this problem, what he has given is a pair of surgeons with 20-degree full depth invalid teeth consists of 19 teeth pinion meshing with a 40 teeth gear. The pinion is mounted on the crankshaft of 7.5 single cylinder diesel engine running at 1500 rpm. The driven shaft is connected to two-stage compressor. Assuming a service factor of as 1.5, the pinion as well as gear made of same material or same made of steel 40 C8 with the SUT 600 Newton per mm square. The module and base width of the gears are 4 and 40 mm respectively. So everything is given. No need to design here. Yes, given all the things. Model is given, base width is given, materials is given, number of teeth is given, everything is given. So that means here we are not designing the gate drive or gate drive. So what we are doing here is we are doing the analysis. So what he has asked for that? First, using velocity factor to account for dynamic load, determine the factor of safety. So simple. What it is, he has given everything. What you have to do is you have to calculate what is the factor of safety. So how we can calculate that? So what is your factor of safety? Your factor of safety is nothing but P effective divided by SB divided by P effective. This is the factor of safety. So while calculating this P effective, you need to go for the you need to use the elastic factor to account for the dynamic load. So that's it. So SB you can easily calculate. The formula for SB is M into B into sigma B into Y. So everything is known. M is given directly for 4 mm, B is given as 40 mm, sigma B you can calculate SUT by 3, which is 200. Only thing is, per pinion, since both are made of same material, so you have to take the data corresponding to the pinion, because pinion is the weaker one. So for pinion having a 19th teeth, you can pick the value of form factor. You'll get all those things. So once you got this, so you got the SB value. Then once you got the SB value, then you need to compute what is P effective. P effective is nothing but PT into CV by CS. CS by CV. CS by CV. So CS is directly given as 1.5. So then you require PT. What is the formula for PT? Formula for PT is nothing but 2mt by diameter of the picture diameter of the pinion. So dp dash. So you will get PT value also. Then he has given the values for everything. So then you can calculate the pitch line value. No need to assume that here, because he has given the number of teeth. He has given the module. So pinion diameter dp dash you will get directly. dp dash is nothing but number of teeth on the pinion. That is 19 into module 4. So therefore it is 36 mm. Not 36. 76 mm. So 19 into 4 is going to be 76 mm. Then you can calculate V. V is nothing but 5 D P dash and then NP divided by 60,000. This is the formula what we are using. So in this, dP is 76 and the pinion speed is given as 1500 rpm. So everything is known. You can calculate V. Once you know V value, based on its value, whether you have to take you have to choose the formula for CS, whether it is 3 by 3 plus V or 6 by 6 plus V or something like 5.6 divided by 5.6 plus root V, like that. You can choose the CS value. Once you choose the CS value, you can calculate P effective. Then your SV divided by P effective is nothing but the factor of safety. So that is the solution for this one. Then second one is, if factor of safety is 2 for the fitting failure, recommended surface hardness. So if you take factor of safety as 2, then ask us calculate what is the recommended, what is the required surface hardness for the gauge. So that means you need to calculate the BHN. So for that, if you know the wave strength equation, so you need to equate the wave strength equation. In that wave strength equation, you have a formula, and there is a relation between BHN and this wave strength. From that equation, straight away we will get this answer for this question. Then next one, if gears are machined to meet specifications of grade 8, determine the factor of safety for bending using Buckingham's 5 equation for dynamic load. So here this is different now. So in the first case, you are using the velocity factor to account for the dynamic load. But in the third part of the problem, he asked us, while calculating the dynamic load, don't use the velocity factor approach. You need to use the Buckingham equation to calculate the dynamic load. So then, with that, so he has given a grade 8. So that means you need to calculate what is the error E in that Buckingham's equation. Then, so to calculate this E, you require this grade 8. That's why he mentioned it as grade 8. So then, once you calculate PD now, in case if you want to use this equation, your effective load is nothing but PT into CS plus PD. This is the equation, your P effective. P effective is going to be PT into CS into PD. So now if you calculate PD, again in the beginning itself SB, it is not going to change. Whether you are using velocity factor approach or Buckingham's equation, your bearing strength is going to be same. SB remains same. So whatever SB used it here, use the same SB here. SB by only P effective is going to change. P effective will give you the factor of safety. So now if the factor of safety is satisfactory, that means if it is given as a 1.5 here, the required factor of safety is 1.5, something like the is given. So service factor is given, factor of safety is not given. Okay, whatever value got in here, if I satisfy with that value, that means if that value is within this range, 1.5 to 2, then I can say it is okay. Or else, if that is not the case, then what you need to do is you need to modify your gear design. So is the gear design satisfactory? So that means whatever you do using this dynamic Buckingham's equation, based on that you got the results. With that results, if your gear design is satisfactory or not, you need to say. If not, what is the method to satisfy the design conditions? How will you modify the design? So that means, so here this is the problem already. This case, if you take a grade 8, it is not getting the, it is not the gear is not having the factor of safety is within the range. So you need to modify the design so that the design is not satisfactory. How you can modify is you need to change this grade, that is surface grade, surface finish grade. So due to that, you can improve the surface hardness so that the dynamic load may be decreased. Once the dynamic load is decreased, automatically the factor of safety goes on increasing. So that is how you can solve this particular problem. So now I'll show you the solution step by step. Okay, right. So if you want to note it down, then I'll give 1 or 2 minutes time. So you can take maximum 2 minutes time to note it down. Then I'll show you the solution also. So just note it down. Okay, is it over?
Yes, sir.
Okay, right. So now we'll see the solution also. So as I explained, so first you need to calculate what is the beam strength, then you need to calculate what is the effective load. Based on that, you can find out the factor of safety for the first part of the question. So for that, given data is power transmitted to be transmitted is 7.5 kilowatts. Speed of the pinion is 1500 rpm. Number of teeth on pinion is 19. Number of teeth on gear is 40. Module is 4 mm. Face width is 40 mm. SUT is 600 Newton per mm square. So both are made of gear and pinion made of same material. So machining grade is 8. So this is for to calculate the dynamic load using Buckingham equation. So first we'll calculate factor of safety based on dynamic load using velocity factor approach. So since both gears are made of same material, the pinion is the weaker than the gear. That is obviously we know that. Lewis form factor for 19 feet is 0.314. So again, this is taken from the data book. So I'm not again and again explaining this one how you choose the form factor. So you should know by this time you should know how to pick the form factor from the data book. Then the permissible bending stress is 1/3 of the ultimate strength. So therefore it is ultimate strength is 600 Newton per mm square. So permissible bending stress is going to be 200 Newton per mm square. Then your beam strength is given by this equation: M into B into sigma B into Y. M is 4, B is 40, sigma B is 200, and Y is 0.314. From that you will get beam strength as 10,048 newtons. Then we need to calculate the P effective. So that for that you need to require PT also. You need to calculate the PT. So for that diameter of the pinion we required. So M into ZP is 4 into 19. Like I already told you, we got it as 76 mm. Then MT is going to be for the MT formula is 60 into 10 power 6 by 2 pi mg. So if you substitute the power is 7.5 kilowatts. Speed of the gear is here it is not speed of the gear, it is speed of the pinion. You have to take NP. So 1500 rpm. So 2 pi. So then you got the torque as 47,746.48 Newton mm. Once you got the MT value, using MT you can calculate PT. So the relation is PT is equal to 2MT by dP. So here 2 into this is the MT value what got, and this is the diameter, circle diameter of the pinion. If you substitute that, you get 1256.49 newtons PT. So then once you know the PT, then you can calculate P effective. So to calculate P effective, you should know what is CS and CV. CS is given as 1.5 directly, but we need to calculate CV. So for that, first you have to compute what is the pitch line velocity. V is given by this formula. So in that 76 is the diameter of the pinion, and 1500 is the speed of the pinion. If you substitute it, you got it as 5.969 meters per second. Then your CV is going to be 3 by 3 plus V. If you substitute that, you'll get it as 0.3345. Then you can calculate your effective load. So effective load is nothing but CS by CV into PT. CS is 1.5, PT is 1256.49 newtons. Just to calculate it here. And then CV is 0.3345. So if you substitute it, you get 5,634.48 newtons. So once you have P effective and SB, you can easily calculate the factor of safety. Factor of safety is nothing but SB by P effective, which is nothing but beam strength. SB is nothing but beam strength, which is we calculated as 10,048 divided by 5,634.48, which comes out as 1.78. So this is the answer. Factor of safety based on velocity factor approach, you are getting the factor of safety as 1.78. Then next question is asked as suggest a suitable surface hardness to the gear teeth. So for that he has given the factor of safety as 2. So therefore surface hardness of the gears with a factor of safety of 2. We need to calculate. So for that you need to take the beam base strength equation. So we know that wear strength is nothing but P effective into Fs, which is given by this one. So P effective we already calculated, that is 5634.48 newtons, and then factor of safety is given as 200. So therefore this should be the wear strength of the your gale. And also this you have another formula for this SW. What is that SW? SW is nothing but Q into B into K in, dp dash into K. So this is the formula for that. So I think I have already. So in that you need to calculate what is Q, what is K also. So anyway, dp we already calculated, that is 76 mm. Previously we calculated. We'll use that data. So B is already given in the problem. No need to compute it. So you need to calculate what is Q, what is K. So we know the formula for Q is 2 into Zg by Zg plus Zp. Then if you substitute the corresponding number of teeth, you will get Q as 1.356. Zg is 40, Zp is 19. So if you substitute it, you get it as 1.356. 2 into 40 divided by 59 comes out as 1.356. So once I got the Q, then I need to calculate K. K is nothing but for a plain carbon steels. This is the formula for K. K is equal to 0.16 into BHN by 100 whole square. So then this is the formula, like I said, B into Q into dp dash into K. So in this, B is 40, Q just we calculated as 1.356, dp is already calculated as 76, and then your K is nothing but K in terms of BHN is going to be given like this, 0.16 into BHN by 100 whole square. So this should be equal to your P effective into Fs. So this is the value we calculated in the previous step as P effective into factor of safety is nothing but 11,268.96 newtons. So we'll substitute that here. So from this we can calculate the BHN directly from this equation. So which comes out as 413.35, which could be round up to 420. So that is the surface requires a 420 BHN. Brinell are this number of 420 required for the surface. Okay, so this is the second part of the solution question. Then we need to see the solution for the third part. In the third part, what he asked is you need to use Buckingham's equation to find out the dynamic load instead of velocity approach. That means in the first part of the solution we use the velocity approach. That means we use CV factor to calculate the effective load. But in this part of the problem, he asked us you need to use the Buckingham's equation to calculate the dynamic load. So for that you should know what is the formula for this PD. Formula for PD is given as something 21 into V plus square root C into E into B plus PT divided by something like he has given the formula. So in that formula you should know what is C, what is E. Of course PT is already known to us, V is also known to us. We already calculated the fixed line velocity also. These two parameters you need to calculate additionally, C into V. So this C is nothing but the deformation factor. You have a formula for that, and E is also I will call it as a total error. That is error on the gear plus error on the pinion. So you need to calculate that. So in the data book, in the textbook, he has given all these things, but in the data book, nothing is provided about this one. Here the problem is that one. So if nothing is provided, then how we can proceed it? So there will be doubt over this. So then maybe the supplement, they will provide you all this data as a supplement. So because they are not available in our data book, I don't know, I'm not talking about the new edition, whether they are there in the new edition or not. So I need to verify that. Still I need to verify that. In the old data book, this data is not given about error, how to calculate the error, all these things. But still, whatever procedure he has given in the textbook, we will follow that procedure. If the extracts of textbooks is given as a supplement to you, you can use that so that you can easily solve the problem. Okay, right. So now we'll see that for that the factor of safety based on dynamic load by Buckingham's equation. That is the next part of the question. So for that he mentioned that grade 8. So For grade 8, the error is given by this formula. So, like I said, this is not there in our in the old edition of your data book. In the textbook, he has given this one. So, no need to remember this one. You can't remember all these formulas. If in the data book, if they provide like this, you take it. Otherwise, what you can do is simply you take it as error is going to be very small, or you can ignore that in that particular formula. Okay, so right. So, but if he specifically mentioned he has taken a grade 8, means you have to take this. You have to consider some error. So, because this grade 8 is nothing but how the surface is prepared for the gear 2. So, like there are different surface finishing process like honing, or something, polishing, something like that is there. So, based on that, you will get the surface. Based on the surface roughness, they will classify that one into a different grades. So for grade 8, the surface finish may be different from grade 7 or grade 9. So like that. So therefore, if he mentioned in the problem as about the grade 8 or grade something like that, then you need to consider some sort of error in that profile also. So then only you get the solution. Otherwise, you won't get the solution. So then in that case, if it is not provided, then what you have to do is at least you need to ask the invigilator when required this kind of data, so that we can solve the problem like that. So then at that time they may arrange to you if you ask like that. Okay. So then for opinion, if you know this is the formula for grade 8, this is the formula to calculate the error in this phi again. The formula for phi is given as m plus 0.25 into square root of dp dash. So we know the dp value. So that is pitch circle diameter of the pinion. So then you can using this, we know the module also. If you substitute that, you will get this phi value. Once you know the phi value, you can find out the error for the pinion. Similarly, for gear also you need to calculate that. So therefore, if you substitute all those values, you will get the error on pinion as 23.72 microns. So you remember here, microns means it is 10 power minus 6 meters. Microns means 10 power minus 6 meters. You need to remember that here. Okay. Then similarly, you have to calculate the error in the gear also. So for that, you required a pitch circle diameter of the gear, which is nothing but module into number of teeth on the gear, 4 into 40, which comes out as 160. Then again, you use this formula to calculate this phi and substitute back into this one. So phi is going to be this was the formula. If you substitute 160 here, you will get the phi value. If you substitute into that E expression for E, you will get easy as 24.95 microns. Then but your total error is nothing but sum of error on the pinion and error on the gear. If you add those two, you get 48.67 microns. Then the value of deformation factor C is 11,400 Newton per mm square. So for this material, so only what you have to do is, for the material what he has given, that is 40C8, so you can directly take this value of C from the data book. So once you got this, and we already calculated as 5.969, and B is given as 40 mm, and even PT is also calculated as 1256.49 newtons. Then with this data, you can calculate the dynamic load. So like I said, this is the formula for the dynamic load: 21 into V into CEB plus PT divided by 21V plus square root of CEB into PT. So in that now you know everything. You know B, you know C, you know small e, B, PT values. So therefore, you just substitute all those values in this, you can calculate the dynamic load. If I substitute all the corresponding data into this problem, into this formula, the dynamic load comes out as 10,558.17. So it is a very large value. If you compare to this, see here, your PT is only around 1200, but here your dynamic load is 10,000. So it is magnified by 8 times. So if you multiply this PT by 8, you are getting this value approximately, not exactly. So that means your PT is magnified 8 times if you use Buckingham formula. So that is the drawback of this one. So then with this, then you can calculate the effective load. Effective load is nothing but CS into PT plus PD. CS is given as 1.5, PD is calculated as 1256.49, and PD is just now calculated as 10,555.17. Then this is going to be your P effective. So now with this P effective, we already know what is the beam strength SB we already calculated in the first step of the problem, or in the first part of the problem we calculated SB value. So then that SB is 10,048 newtons. Even we calculated SW also, which is 11,268 newton, 0.96 newtons. Out of these two, SB is the lowest one, so therefore you have to consider the lowest value to compute the factor of safety, not the highest value. Between SB and SW, always you have to choose the smaller value. So you have to use SB to calculate the factor of safety. So then your factor of safety, okay, here you written both, even not only SB, even SW is also less than your effective load. You can see that here your P effective is 12,439 newtons. Here SB is only 10,000 and SW is around 11,000. So both are less than this. That means if you calculate the factor of safety, what you are going to get is, you will get a factor of safety less than 1. Because SB is less than P effective, even SW is also less than P effective. So then you will get a factor of safety is less than 1. Means your design is not satisfactory. If the factor of safety is less than 1.5, even if it is more than 1 also, if it is less than 1.5, you cannot say it is a satisfactory design. So since these two are SB and SW less than FA effective, our design is not satisfactory. So design is unsatisfactory, both from standpoint of strength as well as wear. So that means both strength and wear point of view, the gear tooth is going to fail. So therefore our design is not satisfactory. That means you need to modify the design. So that is the fourth part of the problem. So in the fourth part, he asked us whether the design is satisfactory. Is the design is satisfactory? We can say it is not. Then if it is not satisfactory, how we can modify it and what is the thing you need to do that. So that is the answer for the next part of the question. So since the design is not satisfactory here, we need to change the, or we need to modify the design. So then we'll go for the modification of the design. So how we'll modify that? Still we need to use Buckingham equation only. So but the problem here is, in the previous case, what we got it is your effective load is very large and compared to your PD. So that means if we are able to reduce this effective load, how I can reduce it here? Just by reducing this PD value. So that is the dynamic load value. So the how I can reduce this dynamic load value? See here, if I am choosing proper E value here. So for a given material, so here if you look at this formula, in this formula V is fixed because your V depends upon only diameter of the pinion and speed of the pinion. So NP, V is equal to pi dP NP by 60,000. So therefore these are all fixed values. So I cannot change V value. So then I cannot change the C value also. C depends upon the materials, gear materials. So that is 1 by C1 plus 1 by E1 plus 1 by E2. This is the formula for your C. K over this one. So K is going to be again defined. So that means here once I fix the gear materials, even the C is also not going to change. Phase width B is also fixed. Then if you fix the power transmission, required transmission, that is 7.5 kilowatts, even your PD is also fixed. Then only parameter you can change it is here only E. So that means by reducing the surface error, you can improve the strength. So therefore you need to change the grade for the gear tooth surface such that your dynamic load will reduce. So for that here, instead of original grade 8, now we have chosen grade 6. We will select finer grade for to manufacture the gears and to reduce the dynamic load. It is assumed that gears are manufactured according to grade 6. So now for grade 6, so earlier we have seen for grade 8, we have seen the formula for E. Now for this grade 6, what is the formula for E? It is given as 8 plus 0.635. Again, this will be there in your data book, or else they will supply as a supplement to you. So then with this, and also you can calculate the error on gear as well as pinion. That means you need to repeat the same procedure again. So phi formula is this one. So if you substitute that, you get error on pinion as 11.893 microns. And similarly, you need to calculate what is the error on the gear also. For this, it is It comes out as 12.512 microns. See, now you can see that clearly the error is decreased here, and compared to the previous one, here the error is decreased. So now the total error is going to be 24.45405 microns. Earlier the error is going to be more. So how much it is? 48.67. Now it becomes half. So therefore, obviously, if the error is become half, means your dynamic load will also become half now. So it reduced by 50%. So now again use the formula for the dynamic load and try to compute with this error. Try to compute what is the value of dynamic load. Now the dynamic load comes out as it reduced by half, because here this value is reduced by half. Even approximately this is also reduced by 50%. So 6560.53 newtons is the dynamic load. Now again we calculate the P effective using the same formula. So it is 8445.26 newtons. So then once you have P effective, then you can calculate the factor of safety. So again, like I said, you need to use SB to calculate the factor of safety, because out of these two, SB and SW, your SB is the least value. So you have to always take the least value to compute the factor of safety. So therefore, your factor of safety is equal to SB by P effective. SB we already calculated as 10,048 newtons, and P effective is 8,445.26 newtons. Then the factor of safety comes out as 1.16, 1.19. So it is somewhat greater than 1, but still not as per the requirement. So therefore, what you have to do is, still if you want to increase the power factor of safety, further increase, then what you need to do is, next you have to take another grade. So you have to go for more finer grade, like a grade 5 and grade 4, and you need to repeat the same process, so that the factor of safety will improve and the dynamic load will decrease, and your P effect will also decrease, and your factor of safety will increase. So like this, we need to solve the problem. If he asked us, use the Buckingham equation to compute the effective load. Okay, I think it is clear. So this is how we can solve the problem. Now, since the design factor of safety is more than 1, he said it is satisfactory. Or else, if we feel it is not satisfactory, you need to go for the next try. Okay, is it clear? Or if you have any doubt in this, you can ask your doubts. Still we have 7 more minutes. So in 7 more minutes, I think I can discuss one more problem also. That is also straightforward and simple problem only. So I think okay. So they may be. So this is the problem what I want to discuss. If you don't have any doubt in that previous problem, now you take this problem and then we'll try to discuss the solution for this problem also. So I think with this problem we can close this Spur gears. We can move on to the helical gears in the next class. Okay, if I am able to complete this in this class, then next class we will start helical gears. So before that, first let me know if you have any doubts in that previous problem. That is the important thing. Anyway, we'll consider this problem in the next class. Okay, we'll take up. So only thing is, if you have a doubt regarding how we can choose only in this problem, the additional thing what we discussed there is how to choose this value, this error. So from the data book, in the present data book, this is not there. Or you tell me in your data book he has given anything is given regarding this. Or else, in fact, this formula is also not given in your data book, I think. This formula is there in your data book. In the new edition, those who are having a new edition, this Buckingham dynamic load equation using Buckingham equation, is that formula is available in the data book? I don't think so. This is available in your data book. Is this formula is available? Just refer your data book and just tell me.
Sir, yes, sir.
This formula, what is given?
Maximum dynamic load Fi is equal to incremental load is equal to 21V into CB plus FT by 21V plus root over CB F plus FT.
Okay, so in that case, what he has done is he has given only CB instead of CEB. He has given only CB, right?
Yes, sir. Yes, sir.
This CB here, this CEB replaced by CB only. So the same thing. So it is going to be same. Your CEB is same as CB only. Then okay, so we'll come to that. So if he has given CB, anyway B is given for us. Problem లో B ఇచ్చాడు కదా 40 already ఇచ్చాడు మనకి. Then only what is the thing, what we should know, what is the values for C. So C గురించి ఏమైనా టేబుల్స్ ఇచ్చాడు డేటా బుక్ లో, that also we'll see. Then if that is the okay, then we can say that. So but okay, first you refer the data book, then you tell me whether he has given that C values, any table for C value. So just refer your data book and tell me whether it is given C. Maybe he has given something like this, 1 by E1, E2 by E2, something like that he has given.
Sir, C is equal to dynamic factor is equal to
Uh,
K E1 E2 small e divided by capital E1 plus capital E2 in sir.
C is equal to what he has given, K.
K E1 E2
E1, E2, okay.
small e into
ఇక్కడ వచ్చింది స్మాల్ ఇక్కడ ఇచ్చాడు కదా, ఓకే
sir,
రైట్.
divided by
ఓకే
capital E1 plus capital E2.
ఓకే E1 plus E2.
Dynamic factor ఇచ్చారు సార్.
సో దెన్ అదేలే ఇక్కడ ఏంటంటే మనం ఫార్ములాలో ఇక్కడ సిఈబి అన్నాం, ఇక్కడ వాడు సిబి అని సిఈలు ఫార్ములాలో ఈ కూడా ఇంక్లూడ్ చేశాడు. దట్స్ ఓకే ఫైన్. కే వాల్యూస్ ఇచ్చాడా నీకు ఫార్ములాస్కి? కే వాల్యూస్ 3 వాల్యూస్ ఉంటాయి కదా మనకి డిస్కస్ చేసాం కదా, ఆ టేబుల్ ఇచ్చాడా?
అంటే కే వాల్యూస్ కూడా ఇచ్చారు సార్.
కే ఇచ్చాడు, ఓకే. సో దెన్ ఈ వాల్యూస్
ఏం లేదు సార్ సపరేట్గా.
ఈ వాల్యూ ఇవ్వాలి కదా మరి, వాడు ఫార్ములా ఇచ్చాడంటే ఈ వాల్యూ కూడా ఇవ్వాలి కదమ్మా దాంట్లో. సో సర్ఫేస్ హార్డ్నెస్ ఒక్కసారి చూడు, అవి కూడా ఉంటాయి, ఒకసారి వెరిఫై చేయండి దాంట్లో కూడా.
బకింగ్హామ్ ఈక్వేషన్స్ అని చెప్పి అక్కడ ఉన్నాయి సార్ ఇవన్నీ.
ఎక్కడ ఉంది బకింగ్? ఏ పేజ్ లో ఉందా మరి బకింగ్హామ్ ఈక్వేషన్ అని?
నాది కొత్త డేటా బుక్ సార్.
కొత్త డేటా బుక్ లో లాస్ట్ లో ఇచ్చాడా? ఎక్కడ ఇచ్చాడు? ఈ డేటా బుక్ లో కనిపించలేదు. పోనీ సి గురించి ఇచ్చాడా?
సార్ సి గురించి చెప్పాం కదా సార్, కే E1 E2
దాంట్లో ఈ ఇచ్చాడా లేదా అంటున్నా, దాంట్లో సిలోనే ఈ ఇచ్చాడా లేదా?
అంటే ఈ గురించి ఏం మాట్లాడలేదు సార్ అక్కడ.
సో ఓకే, ఎగ్జామినేషన్ సెక్షన్ నుంచి నేను డేటా తీసుకొస్తాను సార్, తీసుకొచ్చి రేపు చూద్దాం. అయితే రేపు డిస్కస్ వెరిఫై చేస్తాను దాంట్లో. సో దాంట్లో వెరిఫై చేసి ఏముందో చూసి దాన్ని బట్టి ఎలా ఎలా అప్రోచ్ అవ్వాలనేది చూద్దాం మనం. ఓకే, ఒకసారి వాళ్ళు కూడా ఏ సప్లిమెంటరీ కింద ఏం వేస్తారో అది కూడా చూసి అది కూడా చెప్తాను నేను ఒకసారి. సో దాన్ని బట్టి okay, I think are you able to hear me?
ఎస్ సార్.
ఓకే రైట్. సో టైం అయిపోయింది ఆల్రెడీ 12 o'clock అయింది కదా, విల్ క్లోజ్ ఇట్. రేపు నేను డేటా బుక్ వెరిఫై చేసి ఐ విల్ టెల్ యూ వాట్ యు ఆర్ గోయింగ్ టు గెట్, వాట్ ఆర్ ద ఫార్ములాస్, ఆల్ దీస్ థింగ్స్, రైట్? హౌ టు ప్రొసీడ్.
సార్ రేపు ఎప్పుడు సార్ పీరియడ్?
ఓకే సార్.
రేపు ఫస్ట్ అవర్ ఉందిగా మనకి, వి హావ్ ఫస్ట్ అవర్.
అంటే రేపు నుంచి ఆన్లైన్ ల్యాబ్స్ అన్నారు సార్. ఇవాళ అయిపోయినాయి క్లాసెస్. రేపు
ఆన్లైన్ ల్యాబ్ పోస్ట్పోయిన మెసేజ్ వచ్చింది కదా మీకు ఎప్పుడు? చూడలేదు అది
సార్. ఆన్లైన్ సార్.
ఆన్లైన్ ల్యాబ్ లా?
ఎస్ సార్.
షెడ్యూల్ ఇచ్చారా మీకు?
షెడ్యూల్ ఇచ్చారు కానీ ఆఫ్లైన్ ఏ ఫాలో అవుతానన్నారు సార్. అంటే మెకానికల్ గ్రూప్ లో పెట్టారు సార్. ఆన్లైన్ లో జరుగుతాయి, తర్వాత ఆఫ్లైన్ లో జరుగుతాయి అని పెట్టారు సార్.
ఆన్లైన్ లో మీకు ఏం జరుగుతుంది? ఆన్లైన్ లో ఇంతకుముందు జరిగింది ఆల్రెడీ ఆన్లైన్ లో. నాకైతే మరి లేదు ఇన్ఫర్మేషన్. నేను చూసి అది కూడా అయితే నేను కన్ఫర్మేషన్ చేసి చెప్తాను. నేనైతే ఎప్పుడు క్లాస్ అయినది నేను మీకు వాట్సాప్ గ్రూప్ లో పెడతాను. మెక్ అఫీషియల్ అని ఏదో ఉంది కదా వాట్సాప్ గ్రూప్, దాంట్లో నేను అప్డేట్ చేస్తాను మీ అందరికైతే. సో ఏంటి క్లాస్ సిచ్యువేషన్ ఏంటి, ల్యాబ్లో ఏంటి, వాటి పరిస్థితి ఏంటి కనుక్కొని నేను చెప్తాను అది కూడా అయితే. ఓకేనా?
ఓకే సార్.
సో క్లోజ్ చేద్దాం క్లాసు. అటెండెన్స్ షీట్ పెట్టి ఆల్రెడీ దానికి రెస్పాండ్ అయ్యి మీరు కూడా క్లోజ్ చేయండి. ఐఎమ్ క్లోజింగ్ ద క్లాస్.